everybody, welcome back to Just to Pass, and in today's video we're going to be doing a question on forces and motion. In particular, we're going to be doing a forces and motion question about the elevator. The question was taken from Firasat SPM. It's a good workbook to prepare for your exam and to practice exam style questions. In this question we have two diagrams. Each diagram has a lift and a weighing scale and a box. For diagram 10.1, it is at rest, where else in diagram 10.2, it is moving upwards with an acceleration of 2 meters per second squared. The first question, question A, they ask which weighing scale shows a greater reading. A common mistake a lot of students make is they tend to forget or mismatch which motion causes a greater weight. They forget that if we are going up, is it heavier, or if it's going down, it's heavier, which one has a greater reading. So one of the easiest way, or one of a trick that I use is elevator go up, kg go up. Elevator go down, kg go down. If we follow this rule, in question A, we will see that which weighing scale shows a greater reading. One is at rest and one is moving up. So we're going to take this one right here, which means the answer is diagram 10.2. Now for question B, they ask you to name and label two forces acting on the box. Since this is an elevator, the only motion that they could have is up or down. So if we draw the elevator right here, the only motion you have is up or down. The right and left forces do not exist. The downward force is called weight, and the upwards force will be the normal reaction force. The normal reaction force only occurs when an object is touching the surface. So since the box right here, you can see is touching the surface of the lift, which means it has a normal reaction force. Now we go to question C. In question C, they say if the mass of the box is 45 kgs, what is the reading of the weighing scale in diagram 10.1? This question, we have to tackle it in a few different ways. One of the ways that we have to tackle it is to first understand what do they mean by reading on the weighing scale. If you notice in question D as well, they have this, calculate the reading on the weighing scale. Now this reading on the weighing scale can also be rephrased as apparent weight. And what this apparent weight actually means, it means the normal reaction. So it's just a question indirectly asking you what is the normal reaction of the system, or the normal reaction acting on the object. Before we tackle question C, I want to just give a quick briefing on the three possible outcomes that could exist in this question. When we have a lift, there are three possible things that can happen. Number one is that the lift is stationary. Number two, the lift is moving upwards. And number three, the lift is moving downwards. When the lift is stationary, it means that all the forces are balanced. So the resultant force is 0, equals to R minus W, which also means that the R equals to the W. When the lift is moving upwards, there is a resultant force, but the stronger force is the force that is up, which means in this case, the normal reaction force is more than the weight. That is why the resultant force is moving upwards. So in this sense, the force, the resultant force, equals to the stronger force, which is R, minus the smaller force, which is W. And it's vice versa for situation 3, which means that if the elevator is moving downwards, which means the weight is bigger than the normal reaction force. And this also means that the resultant force equals to the weight, which is the stronger force, minus the normal reaction. So once you look at these three situations, looking at C and D, we know that question C asks for stationary, so we'll take this, and question D asks when the lift is moving upwards, which is this. So we will be using this and we will be using this. Now that we have covered the different situations, let's go to question C. Question C says if the mass is 45 kgs, what is the reading of the weighing scale in 10.1? 10.1 is stationary, which means that the R equals to the W. The upwards force equals to the downward force. And remember again, when they ask you the reading of the weighing scale, this means that they want us to find the R value. Now, how do we find the R value? We know that, put a little formula box here. We know that W equals to mass times gravity. So what we do is R equals to mass times gravitational acceleration, which means R equals to 45. For gravitational acceleration, there are two values, 9.81 and 10. If the question states clearly for you to use 9.81, then you use 9.81. If not, you are able to use 10. And you will get your normal reaction as 450 Newton, which is also the reading in the weighing scale. Question D says, calculate the reading of the weighing scale in diagram 10.2. So diagram 10.2 shows that the elevator is moving upwards. If the elevator is moving upwards, draw right here, normal reaction with the weight down here, and the resultant force or the resultant motion has an acceleration of 2 meters per second square. Again, they ask you what is the reading on the weighing scale, which also means what is the apparent weight, which actually means the normal reaction. Now, using the formula we highlighted just now, what we have is the resultant force equals to the stronger force, which is normal reaction because it's moving upwards, minus the weaker force, which is W. Again, we are finding the normal reaction, which means we move everything to the other side. We move the weight to the other side. We get F plus W equals to R. The F being the resultant force, W being the weight, R being the normal reaction. Now, when we go back to our list of formulas right here, we know that the resultant force not only equals to upward force minus downward force, it also equals to MA. This is Newton's second law. Now, what we can do is we can replace F and W with the mg and the ma. So the F, we replace it with ma, W, we replace it with mg, equals to R. The m value is 45, so we go 45. The a value, you do not use gravitational acceleration. We use the acceleration given in the question right here, the acceleration of the motion, which is 2, plus 45 again, gravitational acceleration is 10, equals to R. We will be getting 540 Newton as your R value, or also the reading in the weighing scale. Now, looking at the answer in D, what we did was we actually proved our answer in A, because our answer in A asks us which weighing scale shows a greater reading, and we said diagram 10.2. By looking at both readings right here, we can see that diagram 10.1 has a weighing scale reading of 450 Newton. Diagram 10.2 has a reading scale of 540 Newton right here. If you found this video helpful, please subscribe to the channel as I'll be uploading more content in the coming weeks. If you have any questions, please comment down below. If you want me to answer more questions on different topics, please comment down below. Until then, talk to you real soon.